Welcome back. This is the Thermodynamics solutions, homework solutions at the South Dakota School of Mines and Technology. This is homework number 9, problem number 3. We are doing other vapor-liquid equilibrium. Specifically, we're doing Henry's law. So this problem is also out of Kretsky. It is 8.47. It says a binary mixture of carbon dioxide and water exists in vapor-liquid equilibrium. The solubility of CO2, so I see the words solubility. I should think Henry's law. I also have a typical gas, CO2, in a liquid, water. Okay. The solubility of CO2 in a liquid has been measured. What is the Henry's law constant for CO2 at these conditions? And it says state, apply all assumptions. Okay, so we're going to make some assumptions, but let's see how. So we recognize this as Henry's law, and so we have to write down our equations. Now this is a vapor-liquid equilibrium Henry's law problem, so I have to recognize this Henry law. I also have to recognize it in the context of I have vapor-liquid equilibrium with the water. Okay, so with the water, the water is going to have, let's do Henry's law. So I'm going to assume that I'm an ideal gas. Okay, I'm also going to assume that I don't need to adjust for temperature. Now, I might need to adjust for temperature, but I'm going to assume I don't. Now, what would I need to do if I need to adjust for temperature? If I need to adjust for temperature, my Henry's law constant, d natural log of Henry's law constant dt at constant P is equal to hi of the vapor minus partial molar enthalpy at infinite dilution over RT squared. Now, so this is why I'm going to assume my Henry's law is constant at that temperature, because I don't have this information. If I'm given that information, then I probably would have to adjust, but I don't have that information. So I'm going to assume my Henry's law constant is constant, truly. Okay, and then I'm an ideal gas, and the other thing is, in the liquid phase, I'm an ideal solution because it's so infinitely, so dilute. So really, this is a Henry's law for kids, Raoult's law for kids problem. So I have y1p is equal to x1 Henry's law constant in 1 and 2, and I have y2p equals x2 Henry's law, p2 sat of the water at those conditions. Okay. Now it's saying so it tells me P is equal to 1 bar. It tells me T is equal to 343.15 K, which is, 150, just 60, 70 K. So, okay, so that's 70 degrees Celsius, sorry. Okay, so that's pretty hot. And then I have an X1, which means I have an X2. Okay, so the only thing I don't know is Henry's law constant, actually. I don't know this one, and I don't know yi. I do know this one, I do know this one. I know this one, I know this one, I know this one, or I can't find that one. I don't know this one. Okay, well that's easy enough. Okay, so I look at what I know and what I don't know. Well, I know everything over here except for y2. Well, y2 is equal to x2 p2 sat over p. Because the other equation I need is the fact that summation of yi is equal to 1. So if y2 is equal to this, y1 is 1 minus that. Okay, so now I have a value for y1, and that's actually the value for y1. I can use that to solve for Henry's law. Okay, so so Henry's law constant is going to equal, at these conditions, let's see here, 1 minus x2 p2 sat over p times p over x1, which I have. Okay, do some simplification. This is going to equal p minus x2 p2 sat over x1. Okay, and then I can just plug and chug. So, again, very straightforward, nothing to it.